What do physics, biology, math, and all other sciences have in common? Answering this question requires some abstract thinking, which is precisely the answer: abstraction. All of these subjects have different fields or levels of abstraction, which are all intricately and elegantly connected by the exact same concept. Let's zoom in on physics for a moment. There is a famous equation that goes like this: P times V equals RT, where P stands for the pressure, V for the specific volume, and T for the temperature. Very simple, right? It elegantly describes the state of an ideal gas. With this equation, it's possible to describe the state of a gas given just two variables, since R is a constant. Okay, but why? For that, we'll have to look a little closer. Our ideal gas is made up of billions of little particles that push each other around. The movement of these particles is governed by a different set of more fundamental laws. If you have enough particles and we apply these laws to all of them, we get back P times V equals RT, which describes the collective motion of all the particles in our system. But why do our particles behave the way they do? For that, we'll have to dig even deeper to the realm of quantum mechanics. From this point of view, the world looks completely different. But still, these fundamental laws govern the behavior of particles and by extension everything from gases to the fusion reactions in our sun to the screen you're looking at. But what if we never looked past our most fundamental laws? We wouldn't be able to see the forest for the trees. Everything we know lives on a certain level of abstraction, and this concept doesn't just apply to physics, technology, and nature. We wouldn't have YouTube, the computers that make the internet, the components that make up the computers, and so on. We would have nothing. Thinking on higher and higher levels has brought us this far and will bring us further than we can imagine. In every field, this process of abstraction goes more or less the same. There's a set of ideas, let's call it X sub k, and you encapsulate all of these ideas in one single idea. Let's call this process F. So encapsulating your set of ideas X sub k in a new level of abstraction would look like F X sub k. Now, this process can be described by this expression: F X sub k equals X sub k plus 1, where k is our current level and k plus 1 is the level we can reach by abstracting once again. Okay, great. Now, let's apply our abstracting function twice. This gives us f of x sub k. Now let's apply our function a bunch of times. You might recognize this as a recursive function, which is something you see all the time in math, but also in computer science, biology, and in every field with some form of abstraction. Nothing is stopping us from applying our function as many times as we want. You can make something as abstract or concrete as you want it to be, simply by thinking on a higher level. This gives you the power to think about an otherwise unfathomable amount of complexity without going insane in the process. Let's now zoom in on one of the latest developments in computer science to see where our abstractions are heading. With the invention of large-scale neural networks, a new frontier is forming in the field of computer science, which calls for a new layer of abstraction. There is simply no way anyone can understand the complexities of large-scale neural networks like this. Therefore, we'll have to change our perspective to look at the layer of thoughts. It seems absurd that something made of metal would be able to think, but is it really? When you have a thought, do you actually have any control over it, or does it kind of appear? Are we spiritual beings that inherit our consciousness from some other realm, or are the thoughts we experience simply the result of tangible neurons firing in ways fully determined by the laws of physics, not unlike how particles turn into gases when looked from afar? If you believe the latter, then all your thoughts essentially boil down to impulses you have no real control over. You're a machine that takes in sensory information and outputs actions. Whatever is happening in your brain is simply cause and effect, perfectly replicable by a machine. Thinking about thoughts is hard though. Thousands of years of philosophy and psychology have made clear that there is no one theory of the mind. There's no logical theorem that elegantly describes the creation and interaction of thoughts the way we describe physical phenomena. The way particle physics leads to classical mechanics is quite clear, but by contrast, the relationship between neuroscience and the level of consciousness isn't as clear-cut. But as we edge closer to the creation of an artificial human mind, we'll undoubtedly uncover more and more about our own inner workings. Abstraction is what led us from sticks to tools, to writing, to mathematics, to science, to computers, to the internet, and to everything we could possibly imagine and more. So if you're feeling like there's nothing left to discover, if you're feeling like we've already made all the breakthroughs and are just picking the low-hanging fruit, know that this is how everyone feels on the edge of a new discovery.